Once understood the properties of a fiber, let's understand the fiber structure at molecular level. When fibers seen in the high magnification microscope, it looks like ribbons or the rods put together. Further magnification into these fibers, we will able to see that it is made from the various layers. Each layer is made up of bundles of lines. These lines in each layer may be straight or at an angle, as you can see in the figure 3. These bundles of lines made up of long chain molecule called as a polymeric chain. When further zoomed into this specific arrangement of a polymeric chain, then we can see two regions. One is ordered, oriented, perfectly lined up region. In this region, molecules are placed straight, oriented, closely with each other, and this region is generally known as a crystalline region. Whereas in some region, polymeric chains are arranged randomly, haphazardly, and this region is referred as amorphous region. So there are basically two regions in the fiber. One is crystalline region, another is amorphous region. A single polymeric chain can pass through the crystalline as well as amorphous region multiple times. So let's look at the definition of crystalline and amorphous region. Crystalline region means it is the region or it is the area where long chain molecules are packed closely and associate in ordered manner. These chains are oriented with each other, and I can show you this is nothing but crystalline region. These regions are ordered region where the molecules are packed closely in ordered manner, right? And this is called, as we all already know, that is this crystalline region. Let's rub it the writings and move again forward and understand the amorphous region. It is the region where long chain molecules placed randomly and loosely bounded with each other. Now, as you can see in this area, the molecular chains are placed randomly. There is no order in between them, and they are placed haphazardly, right? And they are bounded together loosely. So this region is called as amorphous region. In the sense, I can say that in the fiber is made up out of polymeric chain, and polymer chains are placed in the fiber in the crystalline region or amorphous region. Compare each region along with their importance. First, crystalline region. As we know, the polymeric chain in this region placed closely with each other in an ordered manner. When polymeric chain close enough, they forms a bond between adjacent polymeric chain, also known as intermolecular forces. These forces helps gaining their strength to the fiber. If higher number of crystalline region are present in the fiber, then this fiber naturally possesses the higher strength. Second important characteristics of a crystalline region is that they show lower elasticity, meaning when tensile forces applied to these crystalline regions stretches but won't recover 100% soon force is removed. In general, if higher number of crystalline regions are present in the fiber, this fiber is less elastic in nature. Third, high orientation of the chains in this region results into a steeper behavior, meaning the fiber become more rigid. It is less flexible. Crystalline regions are packed bundle of polymeric chain, hence they behave stiffly. In general, if higher number of crystalline regions are present in the fiber, this fiber is less flexible. Crystalline region does not permit absorption of any liquid in between the polymeric chain, and the reason is simple. The reason is compactness of a polymeric chain. These chains are non-elastic and compact. The lipid molecule cannot penetrate and sit there, hence no absorption. In general, if higher number of crystalline regions are present in the fiber, this fiber is less absorbent. Crystalline regions are more resistant to a chemical, meaning they won't quickly degrade due to a chemical attack. Because of higher stiffness in the crystalline region, fiber shows harsh feel. Let's understand the amorphous region. What are the different characteristics of them? Generally, polymeric chain in the amorphous regions are placed randomly. There is no orientation between them and hence no intermolecular bond, so amorphous region shows less strength. In general, if higher number of amorphous regions are present in the fiber, this fiber shows lower strength. Polymeric chain in this region can move in any direction, as well as they can be stretched when force is applied and recover to their original length soon force is removed, meaning amorphous region is elastic in nature. In general, if higher number of amorphous regions are present in the fiber, this fiber is more elastic in nature. Lower orientation of a polymeric chain results into a flexible behavior, meaning fiber become more flexible. Amorphous region allows any liquid to absorb due to the presence of void or space present between this polymeric chain. In general, if higher number of amorphous regions are present in the fiber become more absorbent in nature. Amorphous region is less resistant to a chemical attack, and the flexibility in the chain provides a softer handle. Besides these two, crystalline region and amorphous region, there is another region present in between them. We call it as mesomorphous region, and this is an intermediate region between the crystalline region and amorphous region. It is neither crystalline nor amorphous, it is in between there. That means the polymeric chains are placed in this region somewhat orderly and somewhat disorderly. So the long chain macromolecule, when transition from crystalline region to the amorphous region, there is an region exists, and this intermediate region is called as mesomorphous region. Further zoomed into a region, say amorphous region, we will find the randomly placed polymeric chain. Individual polymeric chain is when further zoomed we will find the composition of polymeric chains. These polymeric chain is made up of joining small molecules together. These small molecules linked with each other in a linear fashion and forms a chain. So these small molecules are called as monomer. Let's look at the definition of a monomer and polymer together. So monomer is a molecule capable of reacting with each other to form a polymer. In a simple word, monomer is a molecule, a single molecule that is having a capacity to react with each other, and they together forms a polymer. Polymer is nothing but a repeating unit of a monomer, forms a long chain molecule called as a polymer. A repeating unit of a monomer means, as we all know, the monomer is nothing but a single molecule. A repeating unit of a single molecule, and when they combine together, they react with each other and forms a long chain, and that long chain is called as polymer. There is another terminology called as polymerisation process. The process in which repeating monomer reacts together to form a polymer. Now, there is a conversion process from monomer to a polymer. That conversion process itself is called as a polymerization process. So in this figure, I just showed you there are several monomers are available, but in the process, what will happen? They react with each other and forms a polymer together. a polymeric chain you can see as the end result. This polymerization process, monomer, polymer, etc., these are the terminologies generally used by a man-made fiber industry. So what are those man-made fiber industry? These industry making man-made fibers. They are not available in the nature. For example, polyester fiber, nylon fiber, polyethylene fiber, polyacrylonitrile fiber. These all fibers are man-made fibers. These are not available in the nature itself. So when you want to create your own fiber, you need to understand what is monomer, what is polymer, what is polymerization process. Generally, these man-made fibers are made into the factories, and the factories converts monomer into a polymer and polymer into a fiber. The whole process of conversion of polymer to preparation of a polymer happens in a reactor. So reactor is nothing but a kind of instrument. It's very similar like our pressure cooker. In this pressure cooker, you just put a monomer, heat it up. Along with the monomer, you just add certain additives, initiators, all other chemicals, and cook it for some times at a high temperature, high pressure, or sometimes in a vacuum, and monomers get converted into a polymer. Now polymer is nothing but a melt, a liquid-like structure, a semi-solid or semi-liquid you can say. So this polymer is prepared at the end of a polymerization process. There is another interesting terminology that is called as degree of polymerization. Individual polymeric chains, as we know, made up of joining the monomers together. Here, how many number of molecules joins together to form a single polymeric chain? That number is nothing but our degree of polymerization. The length of a polymer is specified by the number of repeating unit in a chain. That is called as degree of polymerization. In our example, there is a polymeric chain present over here, which is made up of combining 12 monomers together. So degree of polymerization is nothing but 12. Right. So in our example, it is 12 monomer joins together and forms a polymeric chain. That in that case 12 is degree of polymerization. Degree of polymerization if higher, that means more number of monomers are joined together and forms a very long chain. That is benefited to our textile industry. Longer is the chain, longer higher will be this viscosity, and higher viscosity easily produce or spin a good quality fiber. So degree of polymerization is very important aspect as far as fiber manufacturing is concerned. So degree of polymerization can be controlled by adding some additives or chemicals during the polymerization process. So in that process many number of molecules are joined together to form a very long chain. So longer chain can be acquired by addition of additives during polymerization process. Conversion of a monomer into polymer takes place with a chemical reaction. There are two types of chemical reactions that can happen during the polymerization process. One is condensation polymerization and second one is addition polymerization. In condensation polymerization, the reaction takes place between the monomer with elimination of a small molecule, resulting a growth of chain and forms a polymer. When two monomers joins together, they form a polymer, but along with the polymer, they produce a byproduct. Let's talk about some example at home. When you start making a tea in a kitchen, you put all necessary ingredients, like sugar, tea powder, water and milk. While preparation of a tea, you will notice some steam is also produced along with that. That steam is a byproduct. It eliminates, that is, the water molecule is eliminated from the mixture. Similarly, when polymer is prepared, certain small molecules eliminated. Such a reaction is called as condensation polymerization. Whereas in addition polymerization, the reaction between monomer takes place without elimination of small molecule, the resulting growth of chain and forms a polymer. Here, two monomers are joined together and polymeric chain is formed without any byproduct. Consider you prepared a lemonade. You add water and lemon juices together. Here you haven't produced any byproduct. Both liquid just mixed together. In addition polymerization, no byproduct produced. All monomer joins together as shown in this image. Let's understand the polymerization techniques. Polymerization technique means a method to form a polymer from a monomer. Monomer is available in different states like gas, liquid and solid. The conversion from their respective state into a polymer requires a different technique, that is method. So industry choose a particular method based on characteristics of a monomer. There are 6 different polymerization techniques available: gas phase polymerization, bulk polymerization, solid polymerization, solution polymerization, emulsion polymerization, and last one is suspension polymerization. So let's get started with gas phase polymerization. This method is carried out when monomer is in gaseous state. So monomer available in the gaseous state, and such a gas when need to polymerize, so polymerization takes place on the wall of a reactor at a specific temperature and pressure along with initiator, additives and terminators. This method used to produce polyethylene like fiber. So as you can see, these are the monomers, those are hanging around, and these are available in a gaseous form. So gas need to convert into a polymer, and during the polymerization process, the gas molecules are align themselves, they connected with each other and forms a polymeric chain on the wall of a reactor, and here we are able to get polymer. The second method of polymerization is bulk polymerization. Here monomer is available in the liquid form. With certain conditions of a temperature and pressure, this liquid converts into a polymer. If produced polymer is soluble in the monomer, then its viscosity increases and thick melt of a polymer is the result. This polymer then extruded and fibers are produced. As shown in this figure, the monomers are dancing in the liquid, right, because they are in the liquid stage. Now just by applying a temperature and a particular pressure, these molecules get aligned with each other and they forms a polymeric chain in the liquid state itself. And this liquid is not now become a watery liquid. Its viscosity increases, it's become a thick liquid, and through this thick liquid one can extrude the fiber out of it. This is the third technique to produce polymer. If monomer is available in the solid form, then one can initiate polymerization process by exposing the monomer to a light rays. Polymerization takes place at a temperature lower than the melting temperature of a monomer. Reaction is exothermic when conversion takes place from solid state monomer into a polymer. This is the least preferred technique in the industry. This is a fourth common polymerization technique where reaction mediator used and known as solvent. Initially, monomer is available in a liquid or solid form. They get solubilized into a solvent along with initiator and some additives. Let's take a real life example. What is mean by solubilization process? Solubilization. If salt is mixed into a water, it gets solubilized. In this case, salt is monomer, whereas water is a solvent. Similarly, if monomer is solubilized into a certain solvent, then polymerization process start at a certain temperature. If produced polymer is not soluble into a solvent, then it is precipitated out. In this figure you can see monomer, they are dancing in the liquid. Let's say monomer is available in the liquid form. It is now mixed into this solvent, which is shown in the orange color liquid. Monomer is solubilized into the solvent, and then at a certain range of a temperature, this mixture is converts monomer into a polymeric chain. These monomers are now forming a chain inside a solubilized inside solvent. But if there is a simple condition, the produced monomer is not soluble in a solvent, then it is precipitated out.